Hello folks, and welcome to our last day on notes with functions. And so today we're going to talk about function operations and compositions. All right, your learning target for today is that I can perform function operations and compositions. There are 4 slides and you need to make sure that you get every slide down. But I'm going to make it easier for you. Notice the top of this slide. The top of this slide where it names 4 functions, those are the same every single slide. So you really only have to write what's in that box one time, but make sure that you do every example. Okay? So the 4 functions that I have listed at the top of this page are f of x equals negative 2x, g of x equals x squared plus 4x minus 3, h of x equals 4x squared minus 2x, and j of x, which equals x minus 5. Now if you notice, there are 4 functions here, and if we had them all named y, and I said, go get the y function, you would say, which one, Mrs. Brendan? Because they'd all be the same. But because they have a letter, that helps differentiate which function I am specifically talking about at each given problem. So let's start with the first problem. It says g of x plus 2 h of x's. All right, so what it's telling me is it's telling me that I need the g of x function. So I need to go up to the top and find the g of x function. There it is. I'm going to take that function and bring it down. So I'm going to, in place of the g of x, I'm going to put what it represents, which is x squared plus 4x minus 3. Then this one says, and then it says plus 2 h of x's. So I'm going to go and get my h of x. I'm going to make sure that I put the 2 out in front, and I'm going to put the h of x's in parentheses because it wants 2 times that amount. So I'm going to put the h of x in parentheses and make sure that I remember to multiply it by 2 because it says 2 of them. So I'm going to go ahead and do this problem by adding like terms and using the distributive property. So I've got x squared plus 4x minus 3. I'm going to go ahead and do the distributive property first. 4 times 2 is 8, x squared, and 2 times 2x would be negative 4x. And now I'm going to combine like terms. So I have an x squared and I have 8x squareds. Well, that means I have 9x squareds. Okay? And then I have a 4x and a negative 4x. Well, they cancel each other out. And then what I have left is a negative 3. So the answer to this would be 9x squared minus 3. I just added and performed a function operation, adding functions together. F of x subtract g of x. So now I need to find the f of x function, that's up here. And we know that the f of x function represents 2x. And we know that the g of x function represents x squared plus 4x minus 3. Now if I write it this way, I'm only saying subtract the first term of g of x. This says I want to subtract all of g of x. So when I have a function, I have to make sure that I subtract the whole thing, not just part of it. That's a very important concept right there. So now I can go ahead and use the distributive property. A negative times a positive is a negative times a positive is a negative, and a negative times a negative would be a positive 3. Now that I have subtracted the whole g of x function, I can go ahead and add like terms. And normally we put them in standard form. Remember from Algebra 1 what standard form meant? We put the highest exponent first. So this is my highest exponent, and I don't have any more of those. So I'm going to say negative x squared. Then I'm going to find all the x values. Negative 2x minus 4x would be negative 6x. And then I can bring down the plus 3. That is performing function operations. Okay? Some more function operations. Remember I said the top 4 functions are the same, so you don't need to write those down again. So now we'll go ahead and do the next 2 examples. This one says j of x, and that means multiply. So take j of x and multiply it by h of x. J of x is x minus 5, and I want to multiply that by h of x, which is 4x. I'm going to go ahead and put all these in parentheses. 4x squared minus 2x. Okay, when I'm substituting a function in for its name, I want to make sure that I use parentheses for the entire function. So I've got f minus 5 times 4x squared minus 2x. So we have 2 binomial polynomials here. Remember that from Algebra 1? And we need to do some multiplying. So we're going to take and multiply by double distributing. So first term times first term, that's 4x cubed. X times x squared is x cubed. 4 times 1 is 4. Okay, we took the first. Now we're going to take the first times the second. That's x times negative 2x would be negative 2x squared. We're going to take this negative 5 times the first of the other one. Negative 5 times 4 is negative 20x squared. And negative 5 times negative 2x would be positive 10x. Now I want to do a scan to make sure I have it get it in standard form and add all the like terms together. So here I'd have 4x cubed, because there's no other 4x cubes. I got some x squareds here, 2 different kinds. I have negative 2 and negative 20, which makes negative 22x squared. And then the plus 10 has nothing to be added to, so we just add it to the end. So I just multiplied j of x times h of x. Okay, let's try that one more time. But this time I'm going to do f of x times g of x. Now this time I'm not going to double distribute because I don't have a binomial here. I have a monomial. So with a monomial, what I can do is I can singly distribute. So I can take negative 2x times x squared, which is negative 2x cubed, negative 2x times 4x, which would be negative 8x squared, and negative 2x times negative 3, which would be positive 6x. And they all look like we got the largest to the smallest, and we don't have anything that are like terms. So we can go ahead and just say that is the answer. Okay, let's go on to the next slide. This time it's asking me to perform the operation h of negative 2. So it's asking me to go to the function h, and everywhere I see an x, I'm going to input my negative 2. This is what we did yesterday, this exact kind of problem. This one's just evaluating, okay? So I'm going to go to h of negative 2. Everywhere I see an x, I'm going to plug in a negative 2 using my parentheses. And then I'm going to follow the order of operations. Okay, please excuse my dear Aunt Sally. So parentheses and then exponents. So negative 2 squared, that's going to be 4. So 4 times 4 minus 2 times negative 2. Remember, the h of negative 2 stays the same. Now I do multiplication or division left to right. So 4 times 4 is 16. Negative 2 times negative 2 is a positive 4. Now I add or subtract left to right, and I would get h of negative 2 is equal to 20. Now remember, that means the input of negative 2 gives us an output of 20. So you can write the solution to this as h of negative 2 equals 20, or negative 2 comma 20 in ordered pair. All right, now this next one is kind of tricky. Up until this point, we've been doing function operations. This next one is called a composition. And if I think of the word composition, I'm thinking of the word where when you make a composition or you compose music, you take all sorts of pieces and put it together to make a beautiful piece, okay? So, or if you compose a book, when you're writing a book, you don't just write one chapter. You write, you know, the intro, and then you write some chapters, and then you make sure the last chapter kind of concludes your book. All right, so we're going to compose or put together these functions and make a beautiful function or make another function. Okay, maybe it's not so beautiful, it might look kind of ugly actually, but it'll be a different function. Okay, so this says g of, or j of g of x. So j of g of x. Okay, so another thing you want to think about when you're doing these is that, you know, we don't put our shoes on and then our socks. We always work, you know, inside and then out. We put our socks on and then you put your shoes on. So we want to work with the inside first. Okay, so we need to find g of x. So we're going to go ahead and just bring down the j and say, what is the g of x? Well, the g of x is x squared plus 4x minus 3. That's what g of x represents. Now this function says, go to j, and everywhere you see an x, yeah, instead of plugging in a little old 2 or a negative 2, you got to plug this in for everywhere you see an x. So we're going to go to the j of x. So j of x squared plus 4x minus 3. And everywhere I see an x, well, it's right there, I'm going to plug in x squared plus 4x minus 3. And then subtract 5. So j of, this is, remember, this is g of x. I don't have to write that out because that's so huge. We're going to just go ahead and say j of g of x and make it a little bit easier and shorter. And then what would that answer be? Well, I'm going to take away the parentheses here, get rid of them, and then add like terms. So it'd be x squared plus 4x minus 8. That's our new composed function. Doesn't look exactly like g, it doesn't look exactly like j, but it's a combination of them. Okay? Let's try that again, but let's do g of f of x. Okay? So again, we start with the f of x. Okay, inside out, we're going to plug in that negative 2x in for f. And then we're going to go to the g function, and everywhere we see an x, we're going to plug in a negative 2x. So g of negative 2x is equal to negative 2x squared plus 4 times negative 2x minus 3. Now remember what I said. Again, this seems a little bit complicated, so we can just go back to the original and use the original notation when we're talking about compositions. Okay, only when we're talking about compositions can we do that. All right, so then we are going to go ahead and simplify this. So this says negative 2x squared. That means negative 2x times negative 2x, because exponents mean however many whatever your exponent is, that's how many you have to multiply together to get your answer. Okay, so negative 2x times negative 2x is 4x squared. 4 times 2x, negative 2x, would be negative 8x. Subtract 3. Again, this is not the same function as the f or the g, but again, it's a combination of them. And so those two together composed this new function. Okay, that's all I have for you today. Hopefully you took good notes, and we'll come back tomorrow to work more on compositions and operations. Thank you.